just train a model on some data. If you've ever heard AI explained that way, it skips almost the entire actual job. Building a real AI system is not type a prompt and done. There is an actual process with real stages that every serious AI project goes through. Let's walk through all 5 properly. 5 stages: problem scoping, data acquisition, data exploration, modeling, and evaluation. In that order, every single time. Skip one, and it shows up later as a broken product, not just a missed step. Stage 1, problem scoping. Before touching any data at all, you have to answer one question precisely. What exactly are you trying to predict, and why does it matter to someone? Predict house prices is not a scope. Predict the sale price of a house from its size, so a seller can set a fair asking price, is a scope. Vague goals produce vague, useless models. Stage 2, data acquisition. Now you go get the real data you actually need, not just whatever is easiest to find. This means asking hard questions. Where does this data come from? Is it recent? Is it complete? A model trained on 5-year-old house prices will confidently give you wrong answers today because the data itself is stale. Stage 3, data exploration. Before training anything, you actually look at the data, plot it, sort it, look for patterns, and look for problems. Missing values, outliers, like a mansion accidentally listed at $1. Duplicate entries. This stage catches mistakes that would otherwise poison everything built on top of it. Stage 4, modeling. Only now, after scoping, gathering, and inspecting the data, do you actually pick an algorithm and train it. This is the part everyone pictures when they think of AI, but it's stage 4 of 5, not stage 1. Stage 5, evaluation. Check if the model is actually good, and critically, not just on the data it was trained on. You test it on new data it has never seen before. A model that memorizes its training data looks perfect on paper and fails completely in the real world. Let's make this fully concrete with a real-worked example, start to finish, predicting whether a student will pass an exam. Scoping. Define pass precisely. Is it a score above 60%? A specific grade letter? Get specific, or the whole project drifts. Acquisition. Gather the data that could plausibly predict this: attendance records, hours studied per week, and grades from previous exams. Exploration. Look at that data. Maybe you notice students below 70% attendance almost always score lower. That's a pattern worth keeping. Modeling. Train an algorithm on this data so it learns the relationship between those inputs and the pass or fail outcome. Evaluation. Test it on a fresh batch of students the model has never seen. If it predicts correctly there too, it's actually learned something real, not just memorized the original students. One more, quickly, to show this isn't just about numbers like prices and grades. A spam filter follows the exact same 5 stages. Scope. Catch unwanted email without blocking real messages. Acquire. Thousands of emails already labeled spam or not spam. Explore. Notice spam often has certain words, links, or sender patterns. Model. Train a classifier on those patterns. Evaluate. Test it on new incoming email it's never seen, and check how often it gets it right. Here's why every one of these stages actually matters, not just in theory. Bad scoping means you solve the wrong problem entirely. Technically correct, practically useless. Skipped exploration means hidden data problems silently corrupt your results. And skipped evaluation is the most dangerous one. It means shipping something that looks fine in testing and breaks the moment real users touch it. One more honest thing worth knowing. This process isn't strictly one and done in a straight line. Real teams loop back constantly. Bad results at evaluation often send you straight back to data exploration, or even back to acquisition, to get better data. The 5 stages are the map, but the actual journey loops. You'll find this exact cycle behind almost everything you use. A streaming recommendation engine went through scoping, gathering watch history, exploring viewing patterns, modeling preferences, and evaluating on real viewers before it ever recommended you a single show. A self-driving systems perception model went through the same 5 stages before it was ever allowed near a real road. Let's check what actually stuck. 3 quick questions. Try to answer each one before the answer appears on screen. Question 1. Which stage comes immediately after data acquisition, modeling, data exploration, or evaluation? The answer is data exploration. You look at and understand the data you gathered before you ever train anything on it. Question 2. Why do you evaluate a model on data it has never seen, instead of the data it trained on? The answer is that testing on training data can't reveal memorization. Only new, unseen data proves the model actually learned a real pattern. Question 3. If evaluation reveals the model performs badly, what's the honest next step? Ship it anyway, go back to an earlier stage, or give up? The answer is go back to an earlier stage, usually data exploration or acquisition. That loop back is a normal, expected part of the real process. So, to recap properly, scope the problem precisely. Acquire the right data, not just the easy data. Explore it before trusting it. Model only once you understand what you're working with. Evaluate on data the model has never seen, and expect to loop back. That's not failure, that's the process working. Next up in this series, we go somewhere every AI conversation eventually has to go: bias, privacy, and what happens when AI gets it wrong. Now you know the actual process, not just the buzzwords. Follow AllAboutAIVerse, and let's keep going properly.